Hello everyone. Hopefully this video works this time. This is now my third take. My computer keeps crashing, or Screencastify keeps crashing. I don't know what's going on. Okay. First and foremost, guys, I'm at my house right now. So if my dogs bark or you can hear them walking around, I apologize. I will stop the video, guys, if they start barking at the door or something like that. Just give you guys kind of a heads up. Okay. Now, today is Thursday, which means tomorrow, Friday, you guys have your first quiz for me. Okay, it's going to be on biomes. On Wednesday, you turned in your biomes notes assignment, which had you go through 10 different biomes and realistically break down a couple things. They broke down climate, broke down the plants, and then it also broke down how two biomes interact and work with one another. Okay. In these notes right now, I'm going to go through a bunch of how they interact with each other and just kind of explain a couple different things. These notes are on my website, which I recommend you looking at. But if you want to add additional notes, I recommend that you write it on either the note sheets that I give you, so print them off, or just write in your notebook. Okay, they will help you preparing for the test or preparing for the quiz. Okay, so let's get this going. So first thing I want to talk about is the chaparral in the desert. Both of these images, let me move my face quick for you guys. But both of these images, guys, they look kind of similar. Chaparral in the desert, realistically to the naked eye or to the uneducated eye, you're going to be like, it's the same thing, okay? But it's not. So the desert, if you guys can notice here, is not as green as, say, the chaparral. They still have some hills, still have the red clay dirt. Yeah, they do. But the biggest difference here is the heat and how dry it is. Deserts, guys, are going to be hotter, and they're also going to be a lot drier. Chaparral is going to be warm all year, but it's not going to be as hot. And they're going to get just a little bit more rain. Remember, guys, every time it rains or when we get more water, we're able to grow more things. Think about when it rains outside. When it starts raining in the spring, guys, everything starts blossoming. The grass starts getting green. That's what rain does for us, and some warmer temperatures. Okay? Desert has really hot temperatures and has that warmth, but it doesn't get the moisture to allow a lot of growth. That's why a lot of these plants are super short. They don't look very good. But in the chaparral, they're a lot taller, and they're also green. Okay? Now, moving on to the next one. I want you guys to compare the desert and the tundra to one another. Now, first thing, I just want to talk about this middle piece right here, where it says adapted to low moisture and extreme temperatures. I'm not telling you that the tundra is super hot. And I'm not telling you the desert is super cold. These are exact opposites. The desert's super hot, and the tundra is super cold. These are two extreme temperatures. So those plants that live in these two extreme environments have to be adapted and well-rounded to live in those environments and be able to reproduce in those environments. Now, this does mean plants need to grow and flower quickly in short growing seasons. So if you guys think about that corn we talked about that does nitrogen fixation from the atmosphere, that corn had an 8-month growing period. And a lot of you guys agreed we cannot grow that in Minnesota because we don't have that 8 months. Now in the desert and the tundra, we might have a 2 to 3 month growing period. So those plants that are growing there that need to reach maturity have to do it quickly and rapidly if they actually want to be able to bloom and be able to reproduce. If they don't, then their species end up dying. Now, with this being said though, in the desert, there's not a lot of water. And those plants, things like cactus, have to be able to store and trap water for later use. So if you think of a cactus, and a lot of you guys probably know this, cactuses store water. So if you need additional water, if you're stuck in the desert, you can always cut open a cactus and be able to find some type of moisture. Now the tundra, plants are going to go really low to the ground so they can stay out of the cold and they can stay out of the wind. Now think, if something's really tall and the wind hits it, it has more of a tendency to fall over. But if it's short, you have a better center of gravity. So when the wind hits it, you might just blow over a little bit. Okay. Now, this does not allow really tall things to grow in either areas just because of the water concentrations in both places and the short growing seasons. Okay. Desert and tundra, guys, they do look kind of similar, but they're very different. Okay. This is just an example of two different things. Okay. Now, tropical versus temperate grasslands. Most of you probably researched this and came with the word savanna for tropical grasslands. For temperate grasslands, you guys might have noticed the prairie. Now, what I want you guys to notice first and foremost is this little images down here. The savanna or the tropical grasslands is near the equator. We're talking South America, Africa, Asia, Australia. We're talking near the equator, some warm areas. Now, as far as prairie, there is a little bit near the equator. Yeah, but a lot of it's north of the equator. Okay, so the equator runs somewhere like right around like here. Okay, so a lot of our stuff's north of the equator. We're into the middle of the US, up into Europe here. Okay, we're talking about some colder temperatures. Now, with that being said, both of these places are a lot of grasses and scattered trees and shrubs. Okay, grasslands in the temperate area, so the prairie grasslands, are going to be a lot more grasses than there's going to be trees. And in the savanna, you're going to see more trees and small shrubs compared to the grasses. Okay, both of them are relatively dominated by grass, though. With that being said, temperate grasslands, or the prairie, is known for having the most fertile soil out of all the other biomes. And the reason for this is that they have these really, really deep root systems. So when those deep root systems die and that plant dies, that roots are still in the ground and they start decomposing. And now we know when things decompose, that just adds nutrients to that soil, making that soil nutrient dense. Now, think about this. This area right in here, this is western Minnesota and North Dakota. Western Minnesota and North Dakota guys are very popular for farming. The reason why is because they're fertile soil. Okay, now you guys can make that correlation. And their fertile soil happens is because of these dominated by grassland areas, which add nutrients back into the soil. Okay, this is tropical versus temperate grasslands. Here's a picture of the two. They look kind of similar. The fauna is definitely different, so the animal is definitely different. We got some bison here. We have some zebras here. Very, very different. If you guys go to North Dakota and casually see a zebra walking around, pretty sweet. Take a photo. Call the DNR because it shouldn't be there. Okay? But let's keep moving on. Now, comparing tropical rainforests and temperate deciduous forests. So let me move this image quick so you get to see the word. Temperate deciduous forest. So our temperate deciduous forests are what we are used to. Okay? We get the spring, summer, fall, winter. We have all 4 seasons. Yep, beautiful. We have a big variety and a huge range of temperatures. We can be anywhere from -30 in the wintertime, anywhere to 105 in the summertime, if not hotter. Okay? Now, on the flip side, the tropical rainforest does not get that type of fluctuation. Yes, it's going to get super hot. Yeah, but it's not going to get super cold. We're going to get just a small area of temperatures. Okay, it maintains a constant warm year-round temperature, which means that those plants are never going to lose their leaves. There's no need to. Okay, they can keep running photosynthesis year-round. Now, tropical rainforest guys, since they're going to be warm all year round, they got to be near the equator. But as deciduous forests, they're usually 30 to 50 degrees north of the latitude line, okay, or north of the equator. With that being said, though, they are different, but they are very similar. Both of them have very large trees. Both of them have substantial undergrowth. Now, the biggest difference also besides temperature and the type of plants is the quality of the soil. Your rainforest soil is actually really bad, which a lot of people think it'd be really good because there's a lot of living things there, but it's really poor as it comes to like an agricultural standpoint. And the reason for this is that your root systems in the rainforest are very, very shallow. They don't have to go deep because the water's always right there for them. Now, with plants and other things falling and dying, those nutrients are absorbed so quickly from all the other living things that there's not a lot of nutrients that actually get into the soil or get into the depth of the soil. So that soil then becomes nutrient deficient or nutrient like lease, okay? Compared to something like a deciduous forest where they have deeper roots and they lose their leaves every year, we're putting a lot of organic material into that ground and replenishing those nutrients into that ground very rapidly. Is it as good as prairie grassland? No, but is it still pretty good? Yeah. Now, a lot of you guys have either emailed me or set up a Google Meets with me, and we've talked about this. And realistically, your question was, how do biomes interact with each other? Or how are biomes different between the two? Or how do they work with one another? And I told you to think of mountains. So I'm going to just go through the example quick. Hope you guys hopefully understand it. and hopefully be able to help you guys tie things together for tomorrow's quiz. So, let's say we're near the Pacific Ocean. If anybody's ever been to the ocean before, that wind that comes off the ocean has a lot of moisture in it. It has a high humidity rate, but it blows across the ocean and then onto the land. Now, as it's blowing across land and increasing elevation, going up a mountainside, water starts to condense because of the colder temperatures. As water condenses, we start making thicker and thicker clouds, and those clouds get so full of water that it starts to rain or starts to precipitate. Okay? Now, it's either come in the form of either rain and or snow, but what it's really saying is by the time it gets to the top, there's not any moisture left. The altitude made all that water get squeegeed out or get pushed out onto only one side of the mountain. So when these clouds come across the other side, they have nothing left for them, making this other side something called the rain shadow. And really what the rain shadow means, guys, is that one side of the mountain range is going to be a desert, or it's going to be an area with not a lot of growth. The reason for this is they don't have the water. All this wind and all this water that came from here got sucked up and used already. By the time it got to them, they might get a couple of drops. What I want you guys to think of is, I know most of you guys have seen the movie Holes with Shia LaBeouf. In the movie Holes, Shia LaBeouf is looking off into the distance, and he said something about like, those clouds never seem to come past those hills or come past those mountains. And he was correct. Okay, there were storms on the far side of those mountains all the time. There's storms on the far side of those hills all the time, but they never had enough water to actually crest those mountains or crest those hills and actually bring water to them. Hence why the area where they were was so dry. Okay, now is this true in every instance? No. On the backside of every mountain range, there is not always a desert, but a lot of times you're going to have an area with lower amounts of water. So let's look at the U.S. So this big blue line here, okay, is the mountain range. Okay, this little brown spot down here is the desert. Is that on the one side of the mountains? Yep, correct. But this yellow part here is the temperate grasslands. Okay, these temperate grasslands, they still need a lot of water, but not as much as, say, the taiga or the coniferous forest. And the reason for this, guys, is because they don't get as much water because they're getting pushed past that mountain range. Now, I don't want you to think like there is no rain here, because we are in Minnesota and we're like right here. Do we get a lot of rain? Yes. But the closer you get to these mountains, and in this region, those prairie grassland areas, or that temperate grassland areas, it's going to look different compared to the ones out here. These ones are going to be drier. These ones are going to be more wet. Okay. The reason for this, guys, is because that mountain range is squeezing out all the water. Hopefully that makes sense, and hopefully that helps you guys categorize a couple different things and help you guys combine what different biomes and how they interact with each other. But this is called the rain shadow effect. Okay. Water with some elevation is going to cause precipitation, which is going to cause a dry side and a wet side. Okay. Now, moving on, I have a couple of questions. So the first one says, which biome is this? It's a large amount of rainfall, high temperature, and has poor soil. If you said tropical rainforest, you are correct. There's a large amount of rainfall, guys. There's a high temperature. It also has pretty poor soil, like we talked about earlier. Two main factors that determine where an organism lives. These two factors can be classified under one word. That one word is climate. The two factors are temperature and precipitation. Temperature and precipitation dictate everything. Okay? If it's super cold and not a lot of rain, guys, you're not going to see a lot of things there. Not a lot of life. If it's super hot and there's a lot of rain, you're going to see a lot of life. Things are able to grow then. Okay? So please understand, climate is made up of two things, temperature and precipitation. The climate dictates what can live there, okay, because of the precipitation and because of the temperature. I will come back to this graph, guys. We will talk about this on the last slide, so don't struggle with it now, okay? The most common plants in the taiga biome should be coniferous trees, okay? And most of you guys are just going to call them pine trees. I understand, but the technical proper term is coniferous trees. Think of northern Minnesota and into Canada, guys. That's a perfect example of the taiga biome. Okay, next one says, why are there no tall trees in the tundra? So if we're looking at this image right here, guys, we realize that the tundra is super cold. It's also very dry. Guys, for tall trees to grow, we need to have moisture. No moisture, not a long growth period, then we can't have a lot of things and they can't grow tall. Okay, it does not make sense to. And we also talked earlier that in the tundra, we're not able to get very tall things because we have a layer of permafrost. Now, permafrost realistically means, guys, that underneath your soil level, say about 8 inches down, everything below 8 inches is still frozen and it never actually thaws out. The problem with that is that when you have roots and they're growing and they're growing and they're growing, when they get to that permafrost, they're not going to penetrate this. They're just going to stop, giving trees that want to be taller not a good basis to actually grow and thrive. Because when it's super windy, low amount of roots in the ground, they blow over at a young age and they're not able to keep growing to super high heights. Okay, so there's no tall trees in the tundra, guys, because of a thing called permafrost, not a lot of water, and a very short growing period. Now, this chart, okay, I want you guys to look at this chart. I want you to memorize this chart. I want you to just use it, okay? Every time I talk about biomes, guys, this is the best chart to just at least reference back to. If you're able to depict what this means and be able to explain it, you probably got biomes pretty well, okay? So, first of all, from left to right on the bottom, it goes from wet to dry. And from left to top, or from bottom to top, it goes from hot to cold. And your bottom, hey, shh. We almost had the whole video done without the dogs barking. I apologize. 1 sec. Where's my pause button? Hey! Shh. Shh. Guys. Shh. We're back. Okay. So if you guys can depict this, look at wet and hot areas are going to be your rainforest. Cold and dry areas are going to be your tundra. You will be able to understand where your biome is going to fall into place and how things are going to work and interact with one another. Okay. So things like temperate grassland and savanna, yes, they share the same amount of rain roughly. But the biggest difference here that we talked about earlier is temperature. Okay. So if those temperatures are not the same, they cannot be the same biome, or they cannot contain the same organisms. So this realistically depicts or breaks down what a climate truly is: temperature and precipitation. If you have those two things and you understand what those two words mean, you can then explain what a biome is or what it does. And you can actually make accurate guesses based off those observations. If you guys have any more questions, please feel free to reach out to me and ask me. You guys do have a quiz on Friday. I was almost called a test, but it's just a quiz on Friday. It's roughly 14 points, I believe. It has a couple multiple choice, has some extended response. It is open notes, and because I know I can't regulate what you guys are doing at home. Please do your best. If you guys have questions about things, please ask me. But this is the first of many quizzes, guys, we're going to get into. I'm happy that we're kind of finally getting through biomes. As interesting it is, I think some of the new stuff that we're going to talk about is going to be a little bit better. So if you guys have anything, please reach out to me. Please ask me, and we'll work through those things. Other than that, guys, have a good day. I will see you guys when your next time we're in school. For your distance learners, feel free to always email me, drop in all those different pieces. Okay? Peace out, guys.